Hello and welcome to Golden Geography. Today we're going to be looking at glaciated environments for the OCR Geography A level. And we're going to be thinking about key question 3, how do glacial landforms evolve over time as climate changes? We'll be thinking here both about past climate and future climate changes. We have two particular parts to this. 3A looking at glaciofluvial landforms, and part 3B looking at periglacial landforms and the impact climate change has on those. So let's start with 3A. Glaciofluvial landforms exist as a result of climate change at the end of glacial periods. So here we're very much thinking about how climate has changed in the past. What has happened at the end of ice ages? So if you have a look on the image on the left, we can see little snowflakes where we've had very deep ice ages, very prolonged periods of cold. And the red line shows that after those, you get a rapid increase in temperature, looking from about 4, 5 up to 12 for the global mean temperature in degrees C. And it's at that period of time that we're interested, what's happening as we transition out of ice ages into warm periods called interglacials. And if we have a look at the image on the right, we can see our current interglacial, which is named the Holocene. And if we look right at the very start of the graph, we can see that there was the end of the ice age about 10,000 years ago, and we have a warming period where we transitioned out of that ice age into our current interglacial or warm period. And it's that section of time we want to think about in terms of what happened post-glacially to our landscapes and what that meant for our geomorphic processes. So if we're looking at this period of time, it's called deglaciation because we are having the melting and ablating of glaciers, and that is called deglaciation. And that is occurring because of a warming climate. But that warming climate can also change some of the geomorphic processes that are happening. So we will find during ice ages that erosion, particularly abrasion and plucking, are quite predominant. But as deglaciation takes over, the melting of the ice means that you might find a reduction in those processes. And some of your erosional landforms may no longer be quite as dramatically eroded. They will just stay, and they won't stay the same because they'll be affected by weathering, but they will have less of a development during a period of deglaciation. You might find with increasing temperatures that there is a fluctuation in temperatures around 0 degrees, so processes, geomorphic processes, such as freeze-thaw and frost shattering may increase. So you might find on the sides of your U-shaped valley or the back wall of your quarry that freeze-thaw causes the breakup of those areas and the production of debris. Processes such as transportation will initially increase because you will find that you will have more warm-based glaciers that are moving material. You will also find meltwater will move material and debris a little bit more too. And you should find much more distinctive depositioning taking place and depositional landforms as a result. Deglaciation is key in the development of glaciofluvial processes and landforms. Glaciofluvial processes are very similar to rivers. Rivers or fluvial landforms we know lots about already, but glaciofluvial are ones which come from a glacier. So during periods of deglaciation, you will find that you have an increase in meltwater. And just like rivers, glaciers and their meltwater can move material and deposit it. That material may be sorted. You might find that the larger, heavier material is deposited first by the meltwater, and lighter material moved much greater distances before it's deposited. There can also be an element of seasonality with this, particularly with spring and summer ablation, which would produce heavier meltwater and therefore deposition and during those time periods rather than in winter. So what kind of landforms can we expect to find? Well, kames is a key landform, and we can see in the photo here a kame. It just looks like a mound within the landscape, and effectively that is what it is, but it is formed during deglaciation. So you will find on a glacier that we have supraglacial rivers, and they will transport material, and occasionally they will flow down a moulin, a hole or a crevasse within a glacier. And as they do that, they will deposit material at the bottom of the glacier, and then the water will continue along subglacially. That material will build up, and for as long as it is supported by the glacier, it will be in a kind of tubular shape. But during deglaciation, those glaciers will melt away, and the tubular shape will collapse and form more of a cone shape. The top edges will collapse to form a cone, and eventually greening will take place, which is what we can see in the image. So succession and the development of soils through weathering over time will mean that that cone shape is covered by grass and soils and bushes and vegetation. So very much a key landscape that's formed by glaciofluvial processes. Similarly, we have eskers. Eskers are really the remains of water that ran subglacially, a subglacial river running underneath your glacier. And that subglacial river will carry material with it, and as it loses energy, kinetic energy, it will deposit that material, and it will build up over time. There's an element of seasonality to it as well. So with spring meltwater, there'll be more material, perhaps larger material, that you find deposited here. And once the glacier has melted and retreated during deglaciation, you're left with just that sediment. Often sorted, you can find elements of layers in it that represent seasonality, but it just kind of looks a little bit like a kind of worm running across the landscape. And again, it can be greened, so those developed during the last deglaciation period 10,000 years ago now are covered with grass and vegetation. And finally, we have our outwash plains. So you can see in the photo that where the glacier has melted and you've got this meltwater, it's spreading over a very vast area. And wherever you get meltwater, you can get material deposited, and that deposited material is called outwash plains, sometimes called sanjo as well. It can vary in thickness depending if it's deposited by a valley glacier or an ice sheet, and you might find that you get a bit of sorting as well. So the bigger material or heavier material deposited near the snout of the glacier, and smaller, lighter material deposited further away. Okay, so now we're going to think a little bit about modification. Modification means to change, to develop, to alter some of these areas. And if we think a little bit about our current climate and future climates, some of the landscapes that we have may be modified. So when some of our features like eskers and kames are developed, they are depositional, which means that if there was another ice age and ice was to produce bigger glaciers or bigger ice sheets that covered the areas with the eskers and kames, those eskers and kames would be modified. They might disappear from the landscape. But we can also find in the future that these might develop as well. We can see here we've got projected temperature increase. This is looking at future climate change. And we've got a variation here in projections, but all of them show our climate warming. And as a result of that warming of climate change, then we will find that our current areas of ice will be experiencing deglaciation. And particularly parts of Iceland, they've observed this process of deglaciation, rapid deglaciation, because of climate change in the last 20-30 years. And they've seen, as you can see in the photo, the development of drumlins. And drumlins are another form of depositional landform. And deglaciation, rapid deglaciation, potentially might be one cause of their formation. And as the image shows, sometimes you can get lots of them together, in which case they're called a basket of eggs. Or you could have a field of drumlins. The other thing that might happen in the future that might modify some of these landscapes is a change in the type of weathering that we have. At the moment, in post-glacial air environments, we get a lot of weathering that's physical weathering, so freeze-thaw, frost shattering. But if the temperature in the future goes significantly above 0 degrees centigrade, then that might change and we might have other types of weathering, potentially chemical weathering or physical weathering that might become more dominant and may alter these landscapes in the future. Okay, 3B. Periglacial landforms exist as a result of climate change, both before and or after glacial periods. So let's just clarify, periglacial landscapes are slightly different. You can see on the world map that they're indicated in purple, and they tend to be areas of land that are next to glaciated environments. So they are slightly different. They tend to be areas of permafrost, and they have a biome, a tundra biome that covers that. And you can see examples of that in the images, in the photos on the slide here. So how are they going to be changing because of climate change? Well, climate change and the increase in temperatures will change some of the geomorphic processes that happen here too. And one of the key geomorphic processes that we have is frost heave. And the diagram shows us frost heave. That is effectively where water in the soil forms ice lenses, a bit like contact lenses in their shape, but they are ice, and they draw water to them. So instead of water infiltrating down into the soil and into the rock, actually the cold conditions draw that water to the ice, and those ice lenses grow, and as they grow they expand, particularly expanding upwards, and as they do that they force the ground above them upwards. So it's kind of frosty, it's cold conditions here, and it's heaving, moving the land upwards. So this is a geomorphic process that we have in our periglacial landscapes, but they're very susceptible to temperatures. So we might find that as climate change progresses into the future and temperatures increase, that we have less frost heave, that those ice lenses perhaps start to melt, and the frost heave and the features associated with frost heave, like pattern ground, become less distinctive because those warmer temperatures have reduced the ice lenses. So here we have our pattern ground that is created by frost heave, and that kind of upward movement of the ground created by frost heave moves material to the surface, and then that will roll down to the lower areas around the frost heave and create the pattern ground. But it is very susceptible to changing climate. So areas in periglacial landscapes will have this landscape at the moment, but may not do in the future. Likewise, we have pingus. We have two different types of pingus. We have open system and closed system pingus. Both of those are based around the concept of having an ice core. The ice core is essential in creating the shape that we have with our pingus. So our open system pingus, which we have on the left of the diagram, is where the talc or the unfrozen ground is open to the surface, and that means water can get into this unfrozen non-permafrost ground, and that water will use artisanal pressure to draw more water to it, and it will freeze and it will form an ice lens and it will draw more water to it, and eventually it creates this core that uplifts the land and creates a pingu. Closed system pingus are slightly different. It tends to be where you find a lake, and that lake will then freeze to form the ice lens at the centre, and it will draw water to it through hydrostatic pressure to develop that core and to uplift it. So you will find closed and open system pingus in slightly different areas depending on the permafrost, whether that's continuous or discontinuous. So closed system pingus tend to be more in continuous permafrost, whereas you need discontinuous permafrost with talc for your open system pingus. But both of these are susceptible to climate change. Warmer climates means the ice will suffer. And when we go through periods of deglaciation, we will find that our pingus, that ice core that they have, will collapse and they will become ognives. And you can see that in the picture there. Okay, take a minute, have a look at all of these different subsections and use your colours to work out areas that you're really confident with, mark those in green, areas that you're not sure, amber, and if you have any red areas where you really don't know it, go back and have a look at that part of the video again.